Hello, my name is Lane Kintner. Sorry about the face masks, we're feeling a bit under the weather. But besides that, me and my partner, who will be doing part 2, are going to discuss one of the most well-known parasites of all time, malaria. For those that don't know, malaria is a parasitic disease that commonly infects female Anopheles mosquitoes, which act as a host for the disease, transferring it to mammals, reptiles, and birds. Malaria begins its mosquito cycle after it is ingested by the mosquito during a blood meal. The malaria then begins to infect the mosquito's salivary glands, and is then transferred when it feeds on another organism. After this, it begins to infect human cells using sporozoites, a spore-like stage in the cycle of the malaria parasite. These sporozoites then enter hepatocytes and go through meiotic replication, making thousands of merozoites. The cell is known as a schizont. The buildup of sporozoites causes the hepatocytes to rupture and release thousands of merozoites, which are able to infect red blood cell. Merozoites are able to hide from the immune system when it is inside the red blood cells. It is also where it produces more copies of itself. The red blood cell becomes sticky and sticks to the inner walls of the capillaries, veins, or arteries. After some time, the body's bloodstream will be completely overrun. And when another mosquito comes along and feeds, it will be infected and start this cycle over again. The complications from late-stage malaria can cause fever, and even death. In terms of humans, there are 4 major strains of malaria that threaten us: Plasmodium falciparum, Plasmodium vivax, Plasmodium ovale, and Plasmodium malariae. These 4 strands are the known most dangerous group of malaria to humans, and have been the driving force for some very important genetic mutations amongst humans within the last several thousand years. Malaria has been recorded in instances more than 60 million years ago, far longer than modern humans have existed. However, they originate from the same place, Africa. Because of this, humans have developed a new gene to counteract malaria thousands of years ago called HBB. This gene contains 3 different alleles known as HBS, HBC, and HB. These 3 alleles are found in different amounts in different people all around the world to counter the different kinds of malaria found in each region. For instance, a person in HBS is found strongly in Africans, while HBE is found in Southeast Asia. However, each of these alleles came to exist at a different point in human development, presumably to counter new forms of malaria. The newest allele, HBE, was only developed 5,000 years ago. However, how this gene works for the body can be both positive and negative. But that's a story for my partner in part 2 of this video.